Our second speaker, following on from Julian, warming you up to the idea of making tools, is Jan, who's going to talk to you about improving your Python.
Thank you, and thanks everyone for coming. Yeah, why not writing tools in Python? A little bit about me. I work as a DevOps engineer for a company called Percent in Sydney. We are a cloud consultancy, and we specialize on AWS exclusively. I typically work on clients projects that's infrastructure provisioning with Ansible and CloudFormation, or a lot of CI/CD, Jenkins, Bamboo, code pipeline. I moved into DevOps about 5 years ago, and Python gradually became my go-to language for all sorts of scripting, tooling, as well as for writing lambdas. Before moving into DevOps, I used to be a developer. I guess this means two things. First of all, I'm really, really bad at anything low-level sysops. Like, I have no idea what a BGP route is. The other thing is, I love writing code, which is what this talk is about. Oh yes, and we are hiring, mostly in Sydney and Melbourne. Come and see me for a chat if you want to hear more. So, about this talk, here's how it works. I dump a list of Python features on you, and you just have to start using them. Well, not quite. I will talk about language features, but I mostly want to talk about what I think makes Python code better code. So I'll be talking about things that I find helpful if I write code. And also, I put this talk online, and there's a linked list with a lot of further reading and references, so no need to take notes or so. All right, let's kick things off with a quiz. Looking for a year. I have a couple of hints. If you know the answer, just shout it out. Dark Knight, movie of the year, Lehman Brothers went bankrupt, Spotify launched, and Lady Gaga, if you're into this, had 2 #1 hits. Any ideas? A year? 2008, that's correct. 2008, that is correct. Something else happened in 2008. That is Python 3. Python 3 was launched. It was launched as a partial redesign of APIs, so it mitigated API flaws, and it was decided to launch it as a non-backwards compatible version. Yeah, 2008. That is 11 years ago. Think about how long this is in terms of computer speak. Like, I didn't really look this up, but did we use containers 11 years ago, or deploy into the cloud? I'm pretty sure I didn't even use Git in 2008. So there's one thing I don't quite understand. Why is Python 2 still around? There's a previous version of this talk that I gave, and I would have a few slides where I'm trying to convince people that Python 3 is the better language to use. Today, I'm coming with a single slide only. It's that one. Python 2 will reach, oops, sorry. Ooh. So Python 2 will reach end of life by the end of this year. That's 344 days from now. After that, no more bug fixes, no more security updates. So if you're still in a space where Python 2 is a thing, have this in mind, and maybe this is a good time to move on to Python 3. Talk a little bit about Python version. In my experience, so there's usually quite a version discussion associated with Python. In my experience, it's mostly about Python 2 versus Python 3, and we already covered that. I find it in this space where I write scripts and tools, usually our code is not that complicated. We are not data scientists, we are not implementing applications. So I rarely come across code that requires a specific Python version. And it's actually quite similar for dependencies as well. It's usually like 1, 2, 3 libraries that I import, but it's not massive amounts of things we have to manage. However, I strongly recommend to use a separate Python environment for every project you're working on, to work completely in isolation so that you have your Python version fixed and your dependencies as well for that project. And don't repeat my mistake from 5 years ago and try to pimp your system environment when it wasn't ready for Python 3. So my first tip would be absolutely use Python 3 and also work in isolation for your environments. Use a tool for that. I think most people are using virtual environments, venv. I recently started to look into something called pipenv, which is a bit of syntactic sugar allowed virtual, on top of virtual environments. Just make sure you use a tool for that. Okay, moving on to actually looking at code. I want to talk about readability first. I have a few examples of how I think readability can be improved. I try to group them kind of from obvious to not so obvious. So let's get this super obvious out of the way first. I think every language has coding conventions and naming conventions, so does Python, and it makes a lot of sense to use them. It makes your code easier to read for others, and it also makes it easier for you to read code that others have written. I compare coding conventions a little bit with touch typing. Like, it takes some effort to learn it initially, but once you acquired it, you don't really think about it that much anymore, and it just frees your brain for other things. So, coding conventions. File names. I think there are situations in life where you want to make sure that you're not spoiling something for others. Picking a file name is not one of those. So make sure, if you choose a file name for something you're writing, that it's as descriptive as possible. I find there's nothing more annoying than, say, deploy a Lambda from an S3 bucket where everything is just named Lambda 1 to 15 _ test. So choose a good file name. And this one might be a little less obvious. I want to talk about complex code. I see two issues with the above code. Oh, is it? Oh, can we do anything about it? Yeah. I'm happy to speak in the dark. Oh, that's really hard to read. Yeah. Can we just turn the lights off, maybe? All right. Is that? I'm sorry about that. So there's a comment saying scale out if less than 3 instances. So I have two issues with this code. First of all, that's a bit of a problem. The code only works if you have a comment. Like, if the comment wasn't there, you would not know that this is about scaling, which is not a good thing, because from my experience, comments aren't really coupled to a code. So there's a high chance that comments outdate and that they don't fully reflect the truth anymore, and there's no way to tell. The other thing is that it's a good practice to isolate responsibilities. And something like scaling out is probably something that you want to deal with elsewhere so that you can maintain it in isolation and test it. So in this example, I extracted a method from it, which I think solves both issues quite nicely. So it's super readable, it does not require a comment, it cannot outdate, and the whole scaling logic lives elsewhere and can be maintained there. It can also get more complex over there, but elsewhere. So, tip number 2, naming conventions, of course. Good names is like invaluable, and introducing methods or extracting methods can increase readability big time. Okay, from readable code on to beautiful code. Beauty lies in the eye of the beholder, but it also lies in simplicity a little bit. So I hope this is readable. These are two loops that are doing the exact same thing. They're both counting from 0 to 4, and they're printing the index. Only that the loop on the left-hand side uses twice as many lines as the loop on the right-hand side. I find this is quite a common situation if we're implementing code, that there's usually more than one option to implement what we want to do. And it's usually good to reflect on whether we're using the right construct. And it's usually the better construct if it's more concise and if it's piggybacking on something that the SDK already provides for us, like the range function. Quite often, there's also a Pythonic way of doing things. I want to bring up list comprehension as an example. So the code on the top, we have a list of currency symbols, and we create a new list of, I believe, ASCII codes of these symbols from it, with a for loop. The code at the bottom is doing the exact same thing, only that it uses the Python idiom of list comprehension. That makes it far more concise, and also, once you're used to it, a lot more readable. Also, list comprehension is the way that experienced Python developers would create a list. Another advantage of that is that in the first example, using a for loop, that's not wrong. But if you look at a for loop, there are many, many things you can do with a for loop. If you use list comprehension, it becomes super obvious that you're creating a list, which makes it easier to read, which is good. All right, commenting every single line of code is essential if you're writing an assembler. If you look at this code, I think there are like 3 comments missing, and I already don't understand it. So I think in Python, it's not so important. I found this example where someone made the effort to actually comment every single line of code that he found on the server, that he was writing. And I think this is like going way over the top. It's clearly good intention. However, most of these comments, I think, can safely be left out. As a rule of thumb, if you write comments, don't comment the what you're doing, comment the why. Why is this important? And in this case, it's important because of something I left out. Tip 3, less is more. Functional and simple code is always better. Python idioms are good, and comment only what you cannot say in code. All right, main topic. I want to talk about classes. I know this is something that people don't tend to use very often. I want to start with an example that might be a little contrived. Please bear with me. Let's say we are implementing a calculator that performs calculations on top of a number, like a base number. So in this case, base 10, and we can multiply it, which is cool. It's a good feature. So this goes into production. We are happy. We're making heaps of money with it. And new requirements are coming in. We are now also performing calculations on top of a second number. So we already do base 10, but we now are asked to also perform calculations, say, on a different number. Here is how you could possibly implement it. And here's also the problem. What this code does is it's separating state, the base, from the behavior, the methods we're working with. And this is like asking for trouble, because these 2 lines are identical, but you can't really tell what they're doing unless you exactly understand the state. Obviously, this example is like 10 lines of code on one screen, but imagine this in a bigger script. It's a lot harder to find these kind of issues. So I want to redesign this by using classes. Let's start with an API design. So, oh, sorry, I forgot to mention. Classes, if you have not used classes before, we use class as a blueprint to create object. And an object encapsulates state as well as behavior, data, and methods. So let's design it. We say we create an object from a calculator class by providing a base. Once we've done that, we can call methods on it. Here's how I would implement it. We use the class keyword. Every class has a constructor. It is something that's called internally, and we use it to provide it with a base. And we then use the self keyword to store the base within the object of that calculator, calc base. So that now, if we do our operations, we can actually perform them on top of the base that we stored. This works quite nicely with the example I gave earlier. We now knew up 2 objects of that class. We just provide it with different bases. So it's like kind of foolproof to see what operation you're performing on what object. I have a real-world example for that as well. We recently wrote code that would synchronize between an SFTP server and an S3 server and an S3 bucket. So the way it worked was we needed the connection, and after that we start syncing certain files. Here's a possible implementation. Similar to the calculator, new up an object and provide it with the SFTP server and bucket name credentials, or bucket names. And then later on, once that's established on that object, sync the files you want to sync. Implementation is fairly similar. Again, we use a constructor. This time we provide it with the server name and the bucket name. And we already, in the constructor, create the connection to the SFTP server and store the bucket connection. And then later on, once we're ready to sync, we can actually call that synchronization method, and it can benefit from the fact that we already authenticated against SFTP. Also, here's another small convention. If a method is meant to be called internally, we prefix it with 1 underscore, as opposed to methods that are 2 underscores would be the constructor, and no underscores are methods that are meant to be called from the outside world. All right, this is just a sneak peek into classes, and it was fairly quick. What you can do with classes, you can reuse code. That is, you import a class and you use it elsewhere. You can use inheritance, and you can subclass Python things, having your own collections generators. And you can write unit tests. This is really, really powerful. You write code, and your unit tests it in isolation. Very strong. Tip 4. Encapsulate behavior as well as state. Don't leave them separate. This is like asking for trouble, kind of. Use classes because if you understand them and if you integrate them into how you daily write code, they allow you to understand a lot more advanced features and to use them. All right, last section, the right tool for the job. I was wondering if anyone knew what this code would print. It's a faculty code, and I call it for faculty 3. Any guesses? All right. You probably guessed there was a catch. So if you print it, it doesn't do much. I threw the same code in my IDE, and it says there's a missing closing parenthesis. And I want to make a point that using an IDE helps a lot dealing with complex code in a high-level programming language. So can you do this with your editor? I'm kind of sensing the question. Removing unused imports. Reformatting code automatically according to Python standards. That's a good one. Create a breakpoint, inspect variables at runtime, and change their value. Or just like rename a method across the whole project. You can do all that with an IDE, and I strongly recommend for Python code, look into an IDE and see if you can make use from it, just because you can. And this is actually all I had. Thank you very much. I have 2 more slides. I hope you find it useful. Otherwise, I found this quote from one of the Python core developers. If someone uses features you don't know, just shoot him. And very, very last slide. The talk is online, that's the above link, and there are further reading links on the GitHub project in the middle link. And if you want to reach me, here's my email. Thank you very much.
So we have some time for questions if anyone has questions. And if you don't want to type that link in, it's also linked from the sysadmin miniconf program. I just tweeted it and it was an IRC a little while ago. So any questions?
That's good, I take it.
Stunned silence. Okay, we have about 10 minutes as a room change break until the next speaker. So you have a little bit of a breather, you can have a flick through the slides and see what you can find.